So today we are going to start the statistics, right? And what I have planned till now is to upload like 40 videos for the whole topic, which include descriptive statistics, inferential statistics, and the Bayesian statistics. Okay. Okay. So let's like directly start with the actual business here. So I just want to like give you a big picture of this whole subject, and it's a full long subject, the subject it's so vast. So I just want to like answer this stuff, what is statistics, in three way, which is very very structure ways, like what is statistics and why it actually exists, and how we'll actually do that, right? Okay. So first, let's start with this what. So I prefer to call it like as a science of data, right? So we do have insights, like we do have to take insights and make decision when we don't have all the data, right? This is what written here. So for example, you have some population data, some population you have, right? Or you don't have the data for it, I'm sorry, but you have some population. Let's say you have Delhi, right? If I ask you, like, people, like, what exactly people prefer, I mean, is it Zomato or is it Swiggy, or is it A or is it B? Like, let's be bit general. Let's say or B. So for example, the population of Delhi, let's say 2 crore. So we won't go like to every person, I mean, every uh, individual, and say like what you like, and I'll make a count of it. No. So what generally we do is like we actually sample stuff from this whole population, and there could be different way of sampling. Okay, so this is the sample data. This is sample data. Okay. Now maybe this could be like 1,000 data, or like the 10,000 data, or something like that. Let's say 1,000 data. So you have 1,000 data point here from this whole population now, and now we will do calculation on this data, and like how we'll do it, I'll tell you later when we do visual statistics or something, right? But yeah, for now, let's say we'll do something on this stuff, which is this the sample data, and we calculate some metric. And what exactly is metrical, I'll tell you later about this. We'll calculate some metric, and from those metric we will infer, or we will actually make a conclusion about this population, right? So this is the general way, like we do like mostly inferential statistics, right? So what exactly you hear is like what exactly you see here is like you actually have a insight of this whole population data based on the sample data, right? And and you could make some decision out of it, right? If you want, like, okay, if people are preferring A over B, so let's invest in A only, not B, right? So this is what generally like people do while doing statistics. This is the what. Now why? So if you see around, everything is estimation only, right? Everything is estimation and everything is statistics. So even like it is just like statistics is just way to give you a better way to give you structure this estimation. Okay, not just a vague way to like get some number out of something, right? It give you a structure way, and give you a, I mean, it's a particular method which is very reliable. Okay, to like to make some decision out of, right, some data for sort of that thing. I hope you understand what I'm saying, like why statistics is actually everywhere. Okay. Now you'll ask me like how we'll understand, how we'll actually do the statistics stuff. So for that, you'll have to watch like all the videos which I'm going to put in this playlist, right? till like inferential statistics, will go to learn like most of the way, and the most of the things there which actually help you to infer things out of data. And yeah, so for that you have to watch those videos, right? So yeah, so let's get start with the statistics now. So actually here I divided this whole statistics in two parts. There could be a third part, but for now, for the time being, I'll not want to discuss Bayesian status or something here. Better to, I mean, there could be different patterns. I mean, there could be some different way of doing status also, but that is totally fine. But I just want to like touch these two topics, which is very famous and the best way to find problem out of data, right? So there's one thing which is called descriptive statistics, and there's something called inferential statistics. In descriptive statistics, what exactly you do is summarizing data. So if you heard of mean or median or mode, these are actually a kind of summary to whole of your data, right? Just a single number for whole of data. So we call it like a in descriptive statistics. In inferential statistics is similar to this, right? You have some population data, you take out some sample data now, and you do some calculation on that data and give some inference or decision based on that metric you got, on based on that number you got, right? So this is exactly we call it inferential statistics, where infer population based on sample, right? So I think till now I have given you enough background about statistics. I would still like suggest you to go on YouTube or something like, and you could find like plenty of interesting videos and stuff about statistics, like from where it developed and how it actually uh, progress with the time, right? So yeah, but now actually I want to start with the actual technical stuff, I mean actual mathematical stuff. Okay, so I would say see the main part of like to build a absolute base for whole statistical analysis is first thing if you know about the kind of data you have. Okay, and this is very important, even not just in statistics but in machine learning, or maybe for like AIML, or what data science, whatever that stuff is, right? So you need to have a good idea of data, what you have and what kind of operations you could do that to make that data better, right? So this is what I'm not going to like teach you about, like what kind of operations and what exactly have to do if you have some problem in data, but you could read about that also, right? But I would just tell you like what kind of data you have, and yeah, that will actually help you to understand like whenever, like okay, just let's just first like talk about the actual types. So in general, I would say the data will deal here, maybe in some machine learning project, or maybe oh, I'm sorry for this. Yeah, maybe in some machine learning project, or maybe in some I would say data science project, you will have data divide into two parts. Oh, okay, data. It could be a categorical data, which is like having some category, like I would say like city, or maybe blood group, male, female, right? So we call it like categorical data. Or you could have a numerical column or numerical data. Okay, numerical data. I hope you understand what numerical data is, right? So these could be the broad, like broad two types of data. You have two types of data, kind of data you have, right? Okay, the broad bifurcation here you have. Now I hope you understand like what exactly these two data types are. Now I'll move to a different kind of like different way to actually bifurcate this data, which is more important actually. Whenever you do like machine learning, you actually have to convert these stuff, which is this kind of data, which is categorical data, into numerical form. For that, you have to use some kind of encoding or maybe some kind of yeah, you have to actually label it, right? With you have to actually label it some number, right? That each category you have, right? So for that, I would like to make one. I mean, not for exactly for that, but yeah, there was one more bifurcation. I just want to talk about that first, which is we call data scale. Data scale. Here you could have four types of data. I mean, yeah. This last two are very like intuitive. So I'll just like go through that first. One is called ordinal data. Another is called nominal data. Right? So how these two are different? So these two generally you find in categorical kind of data you have. Okay. Categorical data, right? So in ordinal data you do have a ranking. Okay, so it actually have this data could be actually, it will be easily able to understand using these symbols. You have a ranking. For example, I'm just giving you just example, which we didn't definitely will you'll get to this what exactly this stuff is. You have data like for education. Okay, so someone is 10th pass, 10th pass, and someone is 12th pass. Okay, so I just give you I just represent as a better way. For example, a data column we call education, and someone is 10th pass. Let's say one data, second data is like 12th pass, third data is again 10th pass. Okay, and you could have like, yeah. So in this case, you can see 12th passing 12th is actually greater. I mean, it's better, right? In terms of, for example, you have to hire someone, right? So this is actually better than this stuff, which is 10th class. So I hope you understand this, right? So you do have like infer this data using this symbol, right? This is what I have just said to you. So here, with generally in machine learning, you do ordinal encoding, but I'm not. I just really don't want to go there right now. But yeah, I hope you get it what I was saying. Nominal data is exactly not opposite, but as kind of similar, but they don't have this. You won't able to understand that data using this number, this symbol. I mean, uh, you could able to understand, but this is not in the case of nominal data. You really don't want to do it. Okay, it is more like equal to or not equal to. Again, for example, you have a column name state. There is Bihar, there is Maharashtra, right? So we won't say like Bihar is greater than Maharashtra or Maharashtra is greater than Bihar, right? There's no ranking here, no ranking here, as in this case, right? But yeah, in some case, some problem statement, you may have this thing as a I mean, you could have this ranking also. Okay, right? So in some problem case, some specific problem, but in general it's not, right? So yeah, so it these two can be exchanged anyway, but yeah, I hope you get it. Like whenever you don't have any ranking data, called a nominal data. If you have a ranking data, call it a ordinal data. Very simple, right? And these two are just I just want to just say the name. The name is ratio, and other is interval. Okay, so in ratio, these are generally for numerical data, and in both of the data type you have, you could do like plus, or I mean here interval you could do like plus or minus generally. And in ratio you have like multiplication and division with a perfect zero. But in interval you really don't have a perfect zero there. Okay, So I hope you get my point here. Whatever I just said to you about this stuff, which is uh, this bifurcation of data based on this data scale. This is anyway very important when you do machining stuff. But for now, just understand this way: like there are two kind of data, which is categorical and numerical data, and it could be again divided again the further two groups also, right? Okay. Now let's talk about some different stuff. We do also divide data based on their values. So data values, right? So in that case, we do have again two bifurcation, which we call discrete data set and something called continuous data set. Oh, continuous data set. So it's very evident from the name only. I mean, the data set, the data you have is continuous. It's like, yeah, you have some continuous data set. In discrete, you do have like a discrete points for the data, not a continuous one, right? I don't think like I have to explain much here. Let's talk about there's one more bifurcation I just want to include here, which is not very important, but when you like deal with like different kind of data, metadata and all those stuff, this could be a important factor there, but not in this subject. Yeah. So we call it like I don't have any exact name for this. I mean, just say like some data bifurcation or something, like let's say data type only. So data could be like a sequential data. So these sequential data, like you have a language like Hindi, English, right? Those are based on some sequence, right? The data is have some sequence there. There's something called time series data, which have a component of time also, right? So sequence data, like if you heard of RNNs, LSTMs, those models are meant for this kind of data only. They do have a different stuff of model for this time series database. There's a different database we call this spatial or right spatial database, which have like you have an image. So you do have a data point across a space, or maybe you have a like image, right? You have a image in a space, right? So I hope I am clear with this topic, is what kind of data type you may have. I won't say like you have to mug up all these stuff, but at least know that kind of two data kind. I mean, data there could be two different kind of data possible. It can be a categorical column or can be a numerical column. I hope like till here everything is clear, and I guess this should be enough for the first video. But if there is something I could think of, we can include here. Uh, okay. I just want to like describe this stuff little bit more clearly. Though we'll actually discuss all of this stuff in inferential statistics, in descriptive statistics. But still, it's an introduction video. I really want to like be clear with everything here. So if you say uh, like most statistical mistake happen because people confuse population with sample generally. Okay. So population and sample are two different things. First of all, understanding population is like whole data set available, maybe not accessible by you, but it's available, it's there, maybe not accessible by anyone possible. But in sample is actually a subset of this data set, and it could be easily accessible. I mean, of course, that's why you're actually sampling data. So this thing is actually is the backbone of inferential statistics. If you understand this thing, you actually, like I would say, like you understand the basic reason or basic concept behind it. We have a population data, you actually take out some sample of it and do some calculation on that, right? It's exactly the same thing I've just told you here, right? Okay. Now, so I hope you understand about population and samples, right? Is there okay? I mean, there is something called parameter and other stuff, which I'll actually going to talk about in the next video, or maybe in the initial status video only. That would be great. So okay, I guess this should be enough for the first lecture. But yeah, maybe in the next lecture we more talk about the sampling stuff, like what are the different ways, though we don't have to like know much about this, the way of like sampling and all stuff. But yeah, just to in sake of like completion, I'll add that video also, like how actually we do this sampling, right? Okay, I hope everything is clear till now, what I have just told you, and I have just right here. But yeah, this should be enough, and see you in the next video. Have a great day, guys.